friend. Hello friends. Let us now learn some important points about the attenuation. So, in the attenuation, quality and quantity are the two terms used to express the characteristics of X-ray beam. So, the quality refers to the energy of the X-ray beam, whereas quantity refers to the number of photons in the beam. The intensity of an X-ray beam is the product of number and energy of the photons. So it depends on both quality and quantity of the X-ray beam. A beam of 50 kilo electron volts, that is more energy, has greater energy, greater intensity than the beam with 20 kilo electron volts. So more the energy, more is the intensity, more the number of photons, more is the intensity. Attenuation. Attenuation is the reduction in intensity of an X-ray beam as it traverses matter by either the absorption or deflection of photons from the beam. So if this is the X-ray tube and if this is the patient, then some of the rays, the increase the it has the X-rays passed from X-ray tube to the patient and to the film. Some of the waves will traverse the matter, some of them are absorbed and some of them are reflected. So all of this is attenuation. Because this attenuation is a degree of measure, because the attenuation is a measure of change in intensity, attenuation depends both on the quality and quantity of the beam. For our purpose, it would be simpler to think attenuation only in terms of quantity. Then a reduction in intensity would merely be reduction in number of photons in the beam. So in this lecture, we are going to see the attenuation in monochromatic radiation and in polychromatic radiation. The radiation can be of two types. One, monochromatic radiation. Second, polychromatic radiation. Monochromatic, most of the X-rays are polychromatic radiation. Monochromatic radiation consists of single intensity X-rays, whereas polychromatic radiation intensity varies from minimum to maximum. That is, the intensity of X-rays will be over a range. So polychromatic radiation is most common in X-rays. So first let us learn about monochromatic radiation. So this is a water phantom and 4 centimeters of water phantom is taken. A beam of 1000 photons is directed at the phantom. So the intensity of the beam is decreased to 800 photons in first 1 centimeter. So the attenuation is around 20. So 1000 photons, 20% of 1000 is 200, 200 are decreased, 800 are remaining in the after the first centimeter of water. Then after the second centimeter of water, the attenuation is again 20%. So 800 of that 80% will transmit. So it is around 640 photons, which is 20% less than the first centimeter. Now, if you see the third centimeter, has the X-rays passes through the third centimeter, 512 photons will pass, and finally fourth centimeter, the X-ray photons will be 1410 photons are transmitted through the water phantom. So, with each succeeding centimeter of water, 20% of photons are removed from the beam. Thus, the quality of monochromatic radiation does not change as the X-rays passes through the absorber. Here, energy of the photon is constant. So, if we begin our discussion with a group of photons with energy of 60 kilo electron volts, then the transmitted photons will have the same energy, but the number of photons are decreased. That is, in monochromatic radiation, quality is not affected, mainly the quantity is affected, that is, number of photons are decreased. So, in attenuation of monochromatic radiation, energy is constant, the number of photons, that is the quality of photons, are decreased, so the intensity is decreased. So a change in number or quantity of photons in the primary beam results in decrease in intensity of the beam. So 50% reduction in photons is a 50% reduction in intensity of beam, whereas the attenuation of the polychromatic radiation is even more complicated than the monochromatic radiation. If 50% attenuation of photons will result in 50% decrease in intensity of the beam. Then if you draw a curve with transmitted photons and the absorber thickness plotted on a linear graph paper with transmitted photons on y-axis and the centimeter of water or absorber thickness on the x-axis, then if you see the curve will be little, it is a curve. In this curve, the initial portion of the curve will be is steeper. This initial portion of curve is steeper because more photons are removed from the beam in the by the first few centimeters of absorber. After the beam passes through few centimeters of water, only a few number of photons remain. Although each centimeter of photon removes 20% of the photons, the total number of photons is small, so the end of the curve is flat. Same number plots. So this is the linear graph. So at the end, the curve will be flat. Whereas if the same photons remaining in the beam decreases as the thickness of the absorber increases. So this is called as exponential attenuation. So if we plot the same on a logarithmic paper, you will see if the same is plotted on a logarithmic paper, a straight line is obtained. So when the number of photons remaining in the beam decreases as the percentage of each increment of absorber, as with monochromatic radiation, the attenuation is exponential. So the exponential function plots a straight line on semi-logarithmic paper. So these are the important points about monochromatic radiation. Thank you.